Hello students, we are doing atoms, elements and compounds topic. So this is part 2 and the topic which we are studying is atomic structure and periodic table. So let's see what all we are going to learn in this part 2 video. In this, we are going to study about the subatomic particles, that what is actually there in the atom. See, atom is like this, and it was discovered that there are subatomic particles which are present in an atom, right? The subatomic particles, that means there are minute particles which are very small as compared to the atom, and they are the constituent of an atom. And those subatomic particles were discovered by the volunteers, like the subatomic particle is electron, and it was discovered by J.J. Thomson. This was the first discovery of the subatomic particle. Next, proton, another subatomic particle, it was discovered by E. Goldstein. The third subatomic particle is neutron, and it was discovered by Chadwick. So they were the young scientists who actually discovered the subatomic particles, that is electron, proton and neutrons, and concluded that these particles form the atom. So I think you got it, that subatomic particles are the particles which form atom, or you can say which are present inside the atom. And they are electron, proton and neutron, and they are their discoverers. So now let's study that what is the charge on electron, proton and neutron. See, these particles possess certain charge, like if I talk about electron, right? So electron is negatively charged. I'll write it for you. Electron is negatively charged. Likewise, if I talk of proton, proton has positive charge. And the third subatomic particle, that is neutron, it has no charge. It is neutral. And as you all know, the atom is electrically neutral. Atom possesses no charge, neither negative nor positive. The reason being that in atom, the number of electrons and protons are equal. So if we talk about any atom, any atom you can take, in atom always the number of electrons are equal to number of protons. And that is the reason that atom is electrically neutral. That means it possesses no charge on it. Now, if we talk about the masses, the relative masses of electron, proton and neutron, so the mass of electron is almost negligible. And if we talk about the mass of proton, it is 1 AMU. AMU is atomic mass unit. And this is actually a unit like kg, gram, meter, which is used to, you can say, write or you specify the mass of these subatomic particles. And the mass of neutron is again 1 AMU. So you can see that if we talk about neutron, neutron is neutral. It has no charge on it. But yes, it do possess mass, that is 1 AMU. Now let's study about an interesting topic, that is atomic mass. That what do you mean by atomic mass? As the name specifies, it is clear that in this topic we are going to talk about the mass of an atom, which is called as atomic mass. So how you're going to define the atomic mass of element or the atom of an element? See, the atomic mass in a simple language is the mass of an atom of an element. But the absolute atomic mass of atom can't be measured. The reason being, atom is too small to be isolated, and there are no specific you can say, the accurate techniques to measure such small mass. So, in order to overcome this difficulty, what we do is, we do not find the absolute atomic mass, but yes, we focus on the relative atomic mass. That can be known. Now, what is relative atomic mass? Relative atomic mass means that we can actually relate of mass of one atom with the standard atom in order to know that the given atom XYZ is heavier or lighter than that standard atom. So this is what is relative atomic mass. So that means we can relate the masses. Now, for relating the masses, we need a standard atom whose mass should be known. So the standard atom which was chosen was carbon 12, carbon with mass 12, which can be written as 12 AMU, or you can also say it as 12 mu. So how you're going to define the relative atomic mass? So it is the mass of an atom, or you can say it is an average relative mass of an atom as compared to the atom of C12, whose mass is taken as 12 mu. So that means we can have a mass of any atom XYZ, and we are going to relate it with the mass of carbon 12, whose mass is 12. That means 12 atomic mass unit. So we can define the atomic mass now. It is the number of times an atom is heavier than 1/12 of a carbon atom. The number of times an atom of the element is heavier than 1/12 of carbon atom. So like if I say the atomic mass of sodium is 23. So what do I mean by this? 23 means that sodium is 23 times heavier than 1/12 of carbon atom. So likewise, if I say the mass of helium is 4 mu, or you can write 4 atomic mass unit, or you can write in grams as well. So this specifies that helium is 4 times heavier than 1/12 of carbon atom. So in this way, you are relating the masses. You have a mass of a certain atom and you are relating with the standard atom, that is the carbon 12. So this is what is relative atomic mass. So let's do few question and answer based on the topic. Why neutron is called as neutral particle? So what do you mean by neutral particle? Neutral particle means it possesses no charge. So neutron is said to be neutral particle. The reason being that it possesses no charge on it. Though it possesses the mass, we already studied, that is 1 mu is the mass of the neutron, but it has no charge. That is the reason it is called as neutral particle. Second question is, to which element the mass and charge of proton resembles? We know that proton has +1 unit charge and the mass is 1 AMU. And you know that it resembles which element? It resembles hydrogen. So it doesn't resemble lithium, it doesn't resemble carbon or helium. Yes, it does resemble hydrogen. So hydrogen is an element to which the proton resembles if we talk about mass and its charge. Another question is, what do you mean by statement that atomic mass of sodium is 23? So that means, by saying this, we actually mean that sodium is 23 times heavier than 1/12 of carbon atom. This is how we define the relative mass. We have already discussed. So by saying like this, the atomic mass of sodium is 23, we mean that sodium is 23 times heavier than 1/12 of carbon atom. Another question we have is, which element was chosen as a standard element for calculating the relative atomic masses of an atom? So which atom is there as a standard atom with which we relate the atomic mass? So the options are carbon, hydrogen, nitrogen, or none of them. We know that carbon is an atom which is selected as a standard atom to relate the atomic masses. And which carbon? Carbon 12. That is carbon with 12 atomic mass. Another question is, why hydrogen was rejected as standard element for calculating the relative atomic masses? See, initially the standard element which was selected was hydrogen, but later, or you can say the short span, it was rejected. The reason being that hydrogen exists in different forms with different masses. Like hydrogen exists in a form where it possesses one atomic mass, it exists where it possesses two atomic mass, and it also exists in a form which exists three atomic mass. So these are the different forms. So we cannot take different atomic masses. We need a form with standard atomic mass. And if we try to calculate the average mass of these forms, it came out to be in somehow fraction, that is 1.008 AMU. So in order to avoid any difficulty in calculating the masses, it was rejected and replaced by carbon 12. So that is the reason the hydrogen was rejected as a standard element for calculating the relative atomic mass. Thank you for watching this video. For more learning experience, visit to www.wasrex.com. So with this, the part 2 is finished and we'll take up the other topics in part 3.